Welcome to the Plateau fiber demonstration. We're going to start off by showing some examples of cable. Right here we have a 48 cable. This is what we would call stage 1, which is just actual bare cable. We'd go into stage 2, which would allow us to remove the outer jacket, expose the tubes and the pull strings. Stage 3 is where we've actually pulled some of the pull string through, exposing the tubes to prepare for stripping. In number 4, we're going to add our ground and finish exposing the tubes, removing the outer jacket. Stage 5, the final stage, is once we place it in our closure and we have our tubes exposed and the bare fiber exposed as well. Some examples of the fiber. Here is a 12 count round drop. We have a 12 count plenum cable, which is fire rated for indoor use. Have an example of a fiber tube where it's been kinked. This is damage. This will cause attenuation on the fiber and low light readings. An example of plenum mount by itself. Right here we have a 24 count ribbon fiber. The ribbon is together in a row of 12 compared to an individual fiber. We also have a 48 count aerial fiber here that was shot by a shotgun. I don't know if you can see the BB there in the cable. And then here is another example. This is a 96 fiber. You can see the different amount of tubes, the different colors. We use color coding in everything we do with fiber. It's standard throughout. And then here are some examples of some fiber jumpers which we use to make cross connects in cabinets and COs. Different types of connectors, jumpers, single mode and multi-mode. When we do splice, we use a Fuji. This is a Fuji 60. It's a core alignment machine, meaning that it takes the center conductor, the core of the fiber, and aligns it and splices it together with an arc fuse. Have some basic tools here. Have stripper, cleaver, and heat shrinks. Heat shrinks go over the fiber to protect it after it's been fused. Our basic toolkit goes along with it. And then we have some different closures here. We have our standard Tyco B boot, a D boot, another B boot, and another D boot. This one currently has 528 fibers in it. You can see it. One of the tools we use is a VFL, or visual fault locator. And if you see in the tray there, it's actually showing us a fault. It's a very handy tool. Also in this tray, we label all of our information, directions, what's spliced to what, who's on it, especially cabinets and whatnot. There's about 108 fibers in this tray. And then here's a 296 spliced all out in a D closure. Then we have an A closure going to splice cassettes. These are LC connectors. These are where we connect those jumpers and take them to equipment or to a customer prim. And then what you would see in the alleys are our fiber pedestals. They have information on them as far as route and leads. Of course, warning stickers. And this is just another splice tray where we would actually be hooking up our customers. And then you'll notice on the cables here, we have different colors. Those also give us direction as far as where we're going. Some of the examples of the cable directions is CO is blue, north is orange, green is east, south is brown, slate is west, and red we use for drop. Now we're going to go over here, and Chance is going to splice a fiber for us, and we're going to do a fusion splice Right now Chance has a single fiber. It's the rose fiber. He's going to remove the outer cladding and expose the glass. He's going to take alcohol and clean it. In this process, he's going to put it in a cleaver, which will score it and snap it. It uses a diamond tip blade and then wheels to pull that away. So the end of the fiber is now square. Placing it in the V-groove, in between the electrodes. You can see the electrodes there in the middle. And then he's got a retaining clip there holding the fiber in place. Now he's going to take another fiber, another single, go through the same process of removing the cladding. Clean it with alcohol. Cleave it. Again, giving it the straight edge so they'll match up. And then again, placing it in the machine, in the V-groove, retaining clip, closing the wind protector, and then a simple push of a button. Fibers are aligning. The core is actually the white line in the middle. It's fusing. And now it's one piece of fiber with no loss. And now he'll add a heat shrink to it. Okay, he'll lift the wind protector here, and it's going through a tension test where the retaining clips are actually pulling the fiber, checking the tensile strength on it. Then he'll slide the heat shrink over the fiber, over the splice itself, place it in the heater. The heater is actually melting that heat shrink on. Has a metal rod in it to help give it strength, and it'll take it about 15 seconds. Now he'll remove it from the heater, place it in the cooling tray, and you can see the splice is now protected by the heat shrink. Then we have the finished splice. Go ahead and pull on it, show him the strength. You can see it's strong. He's not going to be able to break that by pulling it. And that concludes our fiber presentation.